You over there. Yeah, you. Come on. It's time for another episode. Okay, grab a cup of tea. Grab a warm cup of tea. Make sure you get really comfortable and sit down because today we're going to be talking about habit. Now, I've mentioned to you and I've made it clear to you that in the past I've gone through some hard times in my life. However, these hard times, and throughout these hard times, the only thing that made it hard was my thinking. The only thing that made the times that I was going through hard was my booming negative thoughts that were knocking, banging on the walls of my head. The only thing that made what I was going through hard is how self-destructive I was to myself. And take this for advice. The the only bad thing that could come out of a situation that you might think is bad is how you might react. The only thing worse is the negative and the angry way in which I acted. If I had continued like that, I would have gone to be depressed with real mental health issues. So, in that moment, when I was sitting so comfortably in rock bottom, when I didn't have any hope or calling, or when my purpose was the only thing pushing me for my willingness to actually work, the only purpose or the only thing pushing me to actually change was the fact that I knew that I could be better. And the fact that I had so much potential and that I couldn't just be wasting it like this. This fear fired up my engines and it got me up. It got me moving. I knew exactly what I wanted to change, why I wanted to change, the steps and the small habits I needed to change, and the action I needed to take so that I could actually change. Alas, there was this voice that would tickle my nerves and whisper lazy thoughts into my ears. The voice that would nag on me to have a break. The part of me that chose the easier path. The other manifestation of self-loathing. The one that's not very talked about very much. And it was the lazy habits that feel so good in the moment, but have a great, ravaging consequence. This vacuous mindset that practices nihilism. Now, what's nihilism, you ask? To keep it short, it's the practice of the highest values de-evaluate themselves. The aim is lacking. Why finds no answers. It's the maltreating of yourself because you believe in no future. Why should I do my homework? Why should I do my chores? Simply, life in this generation make irrational decisions. It's to do something for no reason or doing something just because it feels good. Another way of maltreating yourself is not preparing yourself for the future. To be ignorant or not caring of how it will treat you or how you will handle it in the future. It's the practice of acting without thinking or without motive, and it's social media's best friend. Let me tell you a story about rats. Within the building that houses the Brain and Cognitive Science Department of Massachusetts Institution of Technology and Laboratory, neurologists cut into the skulls of, yep, you heard it right, anesthetized rats, implanting tiny sensors that can record the smallest changes inside their brains. When the rats wake, they hardly seem to notice that there is now a dozen of microscopic wires arranged like neurological spiderwebs inside their heads. The rats in the lab have been illuminated the complexity that occurs in our head whenever we do something as mundane as brush our teeth or back the car in the driveway. When MIT researchers were curious about a lump of neurological tissue known as the basal ganglia, If you picture the brain as an onion composed of layers upon layers of cells, then the outside layer, those closer to the scalp, are generally the most recent additions from the evolutionary perspective. Deeper inside the brain, closer to the brain stem, which is closer to your spinal cord, and of course, we're going to be talking about the anatomy of the brain later on, but let's focus on this. Sorry. When the brain meets the spinal column, are more older and more primitive structures, controlling our automatic behaviors, such as breathing or swallowing, or the startled response we feel when someone leaps out of a bush, the fight or flight response. Towards the center of the skull is a golf ball sized lump of a tissue. This is the basal ganglia, an oval of cells. For years, scientists didn't understand very well. In the early 1990s, the MIT researchers began wondering if the basal ganglia might be integral to habit as well. They noticed that the animals with injured basal ganglia suddenly developed problems with doing basic functions, automatic tasks, like running through mazes or remembering how to open food containers. They decided to experiment by employing new microtechnologies that allowed them to observe in minute detail what was occurring in the minds of rats' heads and which parts of the brain were stimulated, when, and to do what. In surgery, each rat had what it looked like a joystick and dozen of tiny wires inserted into its skull. Afterwards, the animal was placed into a T-shaped maze, with a chocolate laid flat on the floor on the left end. The maze was structured so that the rat was structured behind a party that opened when a loud tick sounded. Initially, the rat heard the click and saw the partition disappear. It would usually wander up and down the center aisle, sniffing at corners and scratching at walls. It appeared to smell the chocolate, but it couldn't figure out how to find it. When it reached the top of the T, it often turned right, away from the chocolate, and then wandered left, sometimes pausing for no obvious reason. Eventually, most rats discovered the reward, but there was no discernible pattern in managing. It seemed as if the rat was taking a leisurely, unthinking stroll. The probes in the rat's head, however, told a whole other story. While each animal wandered through the maze, its brain in particular, its basal ganglia, worked furiously. Each time a rat sniffed the air or scratched the wall, its brain exploded with activity, as if it analyzed the new scents, sights, and sound in real time. The rat was processing information the entire time it wandered. It wasn't just taking a leisurely stroll in the hallway or in the maze. The scientists repeated the experiment again and again, watching how its brain activity changed as it moved through the same route hundreds of times. A series of shifts slowly emerged. The rats stopped sniffing corners and making wrong turns. Instead, they zipped through the maze faster and faster within their brains. And the more times that they did the actual experiment, something unexpected occurred. As each rat learned how to navigate through the maze, and the more familiar they were to navigating the maze, its mental activity decreased. As the route became more automatic, each rat began thinking less and less. They began thinking less. The first time they were introduced to the route, the brain had to work at full power to make sense of the new information that was processed. But after a few days of running the same route, the rat didn't need to scratch the walls or sniff the walls anymore. This caused brain activity associated with scratching and smelling to cease. It didn't need to choose which direction to turn, So the decision-making parts of the brain went quiet. All it had to do was internalize how to sprint through the maze to such a degree that it didn't need to think at all. All it has to do was recall the quickest path to the chocolate. And within a week, the brain structures related to memory had quite. The rats internalized how to sprint through the maze to such a degree that it didn't need to think at all. But that internalization, run straight, hang a left, eat the chocolate, relied upon the basal ganglia. The brain probes indicated this tiny ancient neurological structure seemed to take over as a rat ran faster and faster as the route became familiar and more familiar, and its brain worked less and less. The basal ganglia was central to recall patterns and acting on them. The basal ganglia, in other words, stored habits even while the rest of the brain went to sleep. To see the capacity in action, consider this graph which shows the activity within a rat's skull. As it considers the maze for the first time, the brain working hard the entire time. And after a week, once the route is familiar and scurrying becomes a habit, the brain settles down as it runs through the maze. This process, in which the brain converts a sequence of action in an automatic routine, is known as chunking, and it's the route of how habits form. There's a dozen, if not hundreds, of behavioral chunks that we rely on every day. Some simple. You automatically put toothpaste on your brush before putting it in your mouth. Some, such as getting dressed or making your kids lunch, can be harder or can take different parts of the brain to do. Can I ask you a question? And answer honestly. I don't want you to fake it or to even make it up. What shoe do you put on first? Can you remember that? Every single day you put your shoes on, can you even remember which side or which foot you put on first in your shoe? Another question. What side do you brush first, top or bottom? Can you remember what leg you put your pants through first? Or even what arm you put through your shirt first? Take the action of backing your car out the driveway. When you first learned how to drive, the driveway required a major dose of concentration, and for good reasons. It involved opening the garage, unlocking the car door, adjusting the seat, inserting the key in the ignition, turning it clockwise, moving the rear view and side mirrors, checking for obstacles, putting your foot on the brake, moving your gear shift into reversed, moving your foot into the brake, mentally estimating the distance between the garage and the street while keeping the wheels aligned, and monitoring for upcoming traffic. Calculating reflected images from mirrors into actual distances translated onto actual distances between the bumper, the garbage cans and the hedges, and while applying slight pressure to the gas pedal and brake, and most likely telling the passenger to please stop fiddling with the radio. Whew, that was a lot to think about, and all of that you think about in your first time. However, nowadays, you do all of that every time you have to pull up the street without hardly any thought. The routine occurs by habit. Millions of people perform this intricate ballet every morning unthinkingly because as soon as we pull the car keys, our basal ganglia kicks in, identifying the habit in we stripped our brain related to backing the automobile onto the street. When the habit starts unfolding, our gray matter is free to quiet itself and chase others' thoughts. Which is why we have enough mental capacity to realize that Jimmy forgot his lunchbox inside, or we forgot our phones. Habits, scientists say, emerge because the brain is consistently looking for ways to save effort. When left to its own devices, the brain will look and try its hardest to make anything or any routine into a habit. consistently looking ways to save effort. And that's because it allows our brain to work as much and more often and to work more efficiently. This effort saving instinct is a huge advantage, but conserving mental effort is tricky because our brain powers down, or if it powers down at the wrong moment, we might fail to notice something as important as a predator hiding behind a bush or a speeding car as we pull into the street. And so, our basal ganglia has developed a clever functional system to determine when our basal ganglia takes over so that it takes over in the safe and correct times. It's something when a chunk of behavior starts or ends. To see how it works, notice that the rat's brain activity spikes in the beginning of the maze when the rat hears the click before the participation goes up, when it starts moving, and at the end when it finds the chocolate. Those spikes are the brain's way of determining when to cede control of the habits, which habits to use from behind a partition. For instance, it's difficult for a rat to know whether it's in a maze or whether it's in an unfamiliar cupboard with a cat lurking to eat it. To deal with this uncertainty, the brain spends a lot of effort in the beginning to hold on to something, a cue that offers a hint for which habit to use. For behind a partition, if the rat hears the click, it knows to use the maze habits. If it hears a meow, on the other hand, it chooses a different habit pattern, a reaction, fight or flight. In the end of the activity, when the reward appears, the chocolate, aka the chocolate, the brain makes sure everything is unfolded as expected. This, within our brain's process, is a 3-step loop. First, there's a cue, a trigger that tells our brain to go to automatic mode. It's a trigger that tells your brain in which habits to use. Then there's the routine, which can be physical or mental or emotional system. Finally, there's a reward, which helps your brain figure out the particular habit is worth remembering in the future. Over this time, this loop of cue, behavior, reward, and becomes more and more automatic. The cue and reward becomes intertwined in a major sense of anticipation, and that's when craving emerges. Eventually, whether a chilly MIT laboratory or your driveway, a habit is born. Now, don't worry, I know we looked over this habit loop, but we'll go into it in more detail, okay? Habits aren't destiny, as this episode explains the habit that can be ignored, changed, or replaced. With the reason that the discovery of the habit loop is so important is that it reveals the basic truth. When a habit emerges, the brain stops fully participating in decision making, and it tries to stop and it stops working so hard and the shift and differs its focus to a different task. So unless you deliberately, oops, that's a tricky word, and consciously cause friction to try and stop to fight a habit, unless you find a new routine for the habit to unfold automatically, it will never change. However, simply understanding how habits work, learning the structure of how habits loops, makes it easier to control the functions once you break the habit into its components. We together can fiddle with the gears. Now let's dig into neuroplasticity and how the brain changes its whole entire structure to create memories. But let's stop talking normal. Let's talk science. We know and we can observe the psychological patterns and the reasons behind it, but do we know how and where it's all happening in the brain to serve as what? Let's dive deeper into habits and the coordination function of the brain. Are you serious? Because we're about to talk about science. Okay, so the whole entire reason why your brain can develop new habits and patterns, and the whole entire way our brain can be flexible with doing new things is that it can be malleable, and your brain can change depending on what you are practicing. Do you remember what you ate for lunch yesterday? Well, if you don't, that might be because you don't eat that food every single day. And if you do, there's something wrong with you. You don't practice that thing every day, and it might not be important to you. Let me tell you why. Neuroplasticity. Blame that. What is it, you ask? Neuroplasticity, or brain plasticity, is a process which the brain changes its formation and nerve connections, called synapses, in order to retain information, changing the structure of the nerves to prioritize a piece of information, an image, a memory, depending on its emotional value, how recent it was, or how sudden it was. In other words, it's a process that involves adaptive structural and functional changes to the brain. To elaborate, it's the ability for the nervous system to reshape or change its activity in response to intrinsic or extrinsic sensory input by recognizing its structure, functions, or connections. The brain consists of billions of neurons. Neurons contain a space between them called synapses, communicating with each other through this space, made possible by chemical messages through neurotransmitters. Basically, the presynaptic neuron, the one that takes in the sensory information, releases a neurotransmitter which binds and activates a receptor to the postsynaptic neuron. A typical neuron can have thousands of synapses or connections with other neurons. Together, they form an extremely complex connection that are possible for the functioning of the brain. These synaptic connections can change over time, and this process is called, you guessed it, neuroplasticity. Neuroplasticity is the activity driven and the one that follows the rule, use it or lose it rule. The more frequently used synapses are strengthened, while the rarely used synapses are weakened, eliminated depending on how emotionally strong it is or on how frequent you practice it. Take it as if a relationship. The more you talk to that person, the closer and the stronger your connection will be. But the less and less you talk to that person, the less you'll know about them, and the more you'll grow to be detached, or the more likely it'll be for you guys to lose touch. New activities generate new connections. The changes in the synaptic strength changes can be temporary or long-lasting, depending on the intensity and reoccurrence of the signal the synapses receives. Changes can be temporary or long-lasting depending on the intensity and recurring of the signal and the synapses receives. Neurons can temporarily enhance their connections by releasing more neurotransmitters, activating a new receptor or modifying an existing receptor. This is the base of short-term memory. Long-term memory, on the other hand, long-term memory retention requires strong or sustained activities that produce structural changes to the formation of neurons and brain, such as growth of the new dangered spines and synaptic connections, or even formation of the new neurons. Structural neuroplasticity may also result in enlargement of the cortical areas associated with the increased activity, in shrinkage of those areas that receive less or more activity. For example, in right-handed people, the hand motor region on the left side of the brain, which controls the right hand, is stronger, enduring larger than the other side. Neuroplastic changes can also be functional, meaning the neurons may adapt to a new function when they are sufficiently stimulated, changing and growing new functions as they produce. This is how the brain survives injuries such as strokes, Healthy brain tissue can take over the functions of the damaged areas during the post stroke rehabilitation. Some stimuli, such as stress and physical exercise, can cause certain neurons to switch from one neurotransmitter to another, often converting them to excitatory to inhibitory, or vice versa. This neurotransmitter switching is thought to be the basis of behavioral changes induced by such stimuli. An intriguing example of neuroplasticity, which is the phenomenon of phantom limb sensation. Have you ever seen someone having to have their limbs cut off, or having to have their limbs amputated? In other words, some of these people can still feel their limbs through pains, in which patients have lost a limb during amputation can still feel the limb. For example, patients may feel that the lost arm is still being touched when their face is touched, because an incoming sensory signal from the arm and face project the neighboring regions to the somatosensory cortex. They can emulate or trigger the feeling of the missing limb when the face is touched. The neurotransmitters are perceived and processed as their arms are being touched when they are touching their face, emulating the missing limbs. It is plausible that sensory inputs from the face spill over to the now inactive arm region that no longer receives any input, tricking the brain's higher centers into there goes my neurons, into interpreting the sensation that comes from the absent arm. Now, don't get me wrong. This plasticity that we're talking about doesn't come with a gender or with an age, and this plasticity of the brain is not limited by age, but it's much more remarkable in children as their young brains are still developing. And to give you a visualization, their brains are still like wet clay, easy to be changed, easy to be shaped structurally and to be molded, and for the brain structure to be remolded. Neuroplasticity is essential for normal brain development. It helps create functional brain circuits, and this is the basis of learning, which is why acquiring a new skill such as speaking a new language or playing a new musical instrument is much easier in childhood than adulthood, because their brains are easily adaptive and easily shaping. The easier it is to mold and shape your brain by activities, the more your brain changes, and the more the changes to your brain happen often and all the time, by their magnitude being intensified. Changes brought by neuroplasticity can also be negative and maladaptive, and have unfortunate consequences, especially when they happen in childhood, staying and spring to the brains from life. The negative events shaping their brains more effectively, and they can unfortunately have consequences, especially that can happen in childhood. Childhood traumas are more likely to have a long-lasting effect into a person's life, their brain solidifying and fully growing with that negative adapted structure, thinking or functioning with that structure for a lifetime, as that structure is solidified unto their whole life as their brain developed with that negative structure. The same with addiction. If a child starts early on while their brain is malleable, then they learn and their brain changes its structure to make whatever substances they're taking a necessity, and their brain solidifies with that need, making it really hard to stop that addiction. Neuroplasticity changes happen all the time, but their magnitude depends on the amount of activity that the brain receives. More practice leads to stronger neuroconnected and neuron connections, solidifying the connections and making them stronger and shaping them to be strong and efficient with the more practice that you do. That's why you hear it over and over and over again. Practice makes perfect. More practice leads to more learning. Keeping the brain busy is a way to keep it healthy and effective, strengthening your learning neurons and connections and shaping your brain and sharpening your problem-solving skills to perform at peak performances and stay consistent and efficient with the work that you do. This always allows you to work calmly and efficiently even in the most hard and most stressful situations. Neuroplasticity can either benefit you or worsen your conditions, depending on how you practice your healthy or unhealthy activities, and depending on how early or late you start to practice these activities. Do you play any sports? If you do, have you ever heard of the word coordination? When your coach asks you to practice that serve or practice that shot for better brain to hand coordination, or OMG, my coordination is so bad. That's why I'm so bad at catching. Well, it's not just a saying. This is an actual neurological pathway and a function in the motor parts of the brain. There is no such thing as memory stored in the muscle. Silly. Muscles are merely the motor that pulls on the skeletal system to initiate and create movement. And actual coordinate muscle contractions are initiated through electrical stimuli coming from the several areas of the brain which work through several concerts together to create a movement that is integrated into a specific environment to ensure task completion. And since the human brain is designed to work best when focusing on one single task, our minds are always trying to maximize its attention center and its attention span. It can maximize its attention center by creating memories that can be instantly accessed through simple tasks like motor functions, such as an unconscious and conscious movement that you can do without thinking, such as walking, driving, or throwing a ball. Once memory has been formed, a person can instantly, smoothly, unconsciously, and accurately repeat this physical task with little to no mental effort, strengthening the synapses connection when the movement is being practiced and allowing the person to do it almost without thinking. These memories, which are stored and accessed in the brain, are what most people call muscle memory. But in the scientific world, these processes are referred to as schema, a procedural memory, a discrete motor function, a stored motor task, or what is preferred to be called an automatic neural pathway, preferably by me. The initiation of an automatic neural pathway starts in the frontal lobe, which is the part of the brain that makes your personality, the part that defines your identity, contrasting you and setting you apart from others. This is the area that contains your thoughts, strategies, motives, and decision-making center. This is where you decide on a physical task. Inside your frontal lobe is the premotor cortex. This section of your brain contains a drop-down menu, so to speak, for all your automatic neural pathways. These memories are the easy buttons, the easiest access. Once a memory is picked, a systematic set of commands fire through your motor cortex, which is the part of your brain that actually generates the body movement needed to complete a task, assigning and putting the task to action. After the automatic neural pathway has been activated, the real powerhouse of the brain takes over. The cerebrum, 1 out of 10 of the brain's mass, but it contains 50% of the brain's neurons. It is the automatic center of the brain that controls unconscious movement to keep you alive and the commands of your survival needs, like swallowing, breathing, and digestion. It is the automatic center of your brain that controls your heart rate too. It controls balance, muscle tone, and systematic coordination. And coordination is key to complete any complex movement. Coordination, working in real time to perceive levels of the cerebrum continuously contracting the location of every body part and simultaneously directing where it needs to go to proceed and select a task by the premotor cortex. It proceeds instant updates by the second in real time from sensory neurons and sends instant correction to the outer instant connections to the outer extremities through motor neurons. The cerebrum also has the ability to create its own systematic memory for automatic directing body parts, maintaining posture, alignment, grip, timing, and power. This is why you can walk, text, and chew gum, even hiding it from the teacher, with no mental effort, at least two of these function, and maximum coordination. Frankly, coordination is an oversimplified map of procedural memories, but it serves as a foundational understanding of an automatic neural pathway, or what most people call muscle memory. Circling back to habits and how they are formed, and now we're going to be looking into the psychology of habits. Before we looked into the science of them, now let's look into the psychology, and we'll be using this book called The Power of Habits by Charles Duhigg. I believe that's how you pronounce it. But according to experts from Psychology Today, habits form when new behaviors become automatic and enacted with minimum mental input or conscious awareness. Parallel parking, gambling, exercise, brushing your teeth, and everything that involves habit you have learned all follow the same behavioral and neurological patterns, says Charles Duhigg. The New York Times bestseller advertises his new book, The Power of Habit, explores the science behind why we do what we do, how companies are now working to use habit formation to sell and market products, and how social media is targeting our bad habits through algorithms to keep us hooked. First of all, we dig into how habits are formed. We must know where they're formed. The basal ganglia, as I already said, which controls our motor control below the cerebral cortex, known to control voluntary movements and also may play a critical role into how habits are formed, both good and bad, influencing mood and feeling. As the habit is practiced and it is strengthened, it's almost because of an automatic neural pathway, or as you know it, muscle memory, where the decision part of the brain is no longer needed to initiate or any action. The habit is practiced so much that neurons have changed in order to support and make this movement efficient through neuroplasticity, ultimately becoming a permanent memory that is activated through memory and recognition and is now considered automatic. The neural circuits can perform the habit without conscious thought, or in other words, you don't need to choose to perform the action anymore. It turns out that every habit has a psychological process that's unfolded in behavioral and psychological patterns called a habit loop. We've talked about this before, but let's dig into more detail. This process starts with a cue, or a trigger, that sends your brain to signals to act, go in automatic mode, and let a behavior unfold. Then there's the routine, which is the behavior itself. The third step is the reward. Something that your brain likes, that tells it, remember this brain loop in the future, and something that makes your brain prioritize this habit. Neurologists have traced our habits and our behaviors to the basal ganglia, which also plays a key role in the development of emotions, memories, movements, and pattern recognition. Decisions, meanwhile, are made in a different part of the brain, called the prefrontal cortex. But as soon as this behavior becomes automatic, the decision-making part of your brain shuts off and stops functioning in order to initiate this action or habit. In fact, your brain starts working less and less, as we've said before. The brain can almost completely shut down, meaning that you behave all this mental activity and energy that you can devote to something else. For example, when you're brushing your teeth, that's why you can do it while being half asleep. Or that's why you can go and pee in the bathroom while being asleep. You can do these complex behaviors without being mentally aware of it all, and that's because of the capacity of the basal ganglia to take the behavior and turn it into automatic routine. Studies have shown that people can do these complex automatic behaviors the same way every single day in the same environment. But if they change the environment and behavior pattern, which will change, essentially once the cues change, patterns are broken up. That's why changing habits on a vacation or in another changed environment is proven to be one of the most successful ways to change a habit. That's because your old cues and all of your patterns aren't there anymore. So you have this ability to form new patterns and hopefully be able to carry it into your life and your old environment and to observe behavior or cues and target it to change the cue and reward and overall to change your life patterns. It doesn't seem to work if people do it on their own. At some point, if you're changing a really deep-seated behavior, you're going to have a moment of weakness. And that moment, if you look across a room and think, Jim's kind of a moron, I'm smarter than him, but Jim's been sober for 3 years. And if Jim can do it, I can definitely do it. And that mentality is extremely, enormously powerful. Let me tell you a little story that I learned from this book. Okay, so this story about the one that I learned from the book. So basically, this guy, the guy that actually wrote the book, said that every single day of working, he works in an office job, okay? So every single day when he would work, he said that the same time every day, well, not the exact same time, but this near the same time every day, he would, while he was working, he would get up and he would go to the cafeteria, get a cookie, and then proceed to talk to his employees, to his coworkers. So he saw that this habit was extremely unhealthy. And he was gaining weight from this habit because of the caloric surplus from this cookie every single day. Anyways, he he tried and he tried to stop. Just to summarize this story because it's a very long story. But he tried and tried and tried to stop this habit. But he couldn't. Every single day he would tell himself, I'm not going to buy a cookie. I'm not going to buy a cookie. And what would he end up buying? You guessed it, that cookie. So he asked himself, why am I buying this cookie every day? Is it the cookie that I'm craving or is it something else? And when he asked himself that, he found that he didn't even crave that cookie. So when he looked into the behavioral loop, the habit loop, he saw that the cue, the trigger, was that he was working and he needed a break. And he saw that the reward he was looking for was not the deliciousness of that cookie. No, it was the break or the communication, the refreshing communication that he got out of his employees and just the socialization that he got out of that out of those conversations. So once he looked into the different parts of his behavioral loop, he found that the thing that triggered him to get that cookie was that he wanted to go and talk to his coworkers. And where were his coworkers? Near this cafeteria. So he needed an excuse to go up and to talk to his coworkers. And that cookie wasn't because he wanted it. It was just an excuse to go and talk to his coworkers. So, taking this information, he decided to take action. And the next day, he decided to not buy a cookie, but he decided to go and to talk to his employees, to his coworkers. He got that same level of satisfaction. And it turns out, and he found out that it wasn't the cookie that he was craving, but it was that break. And so once he observed and looked into his behavioral patterns, and once he observed the different parts of this behavioral pattern of the loop, and once he put a conscious effort to stop it, he stopped buying that cookie. And it's been 3 months ever since he's bought a cookie, and he's lost 14 pounds. Amazing, right? Now, of course, all this information that I've been telling you about, the information about neuroplasticity, the information about neurological pathways, otherwise known as muscle memory, automatic neurological pathways, which is muscle memory. We've talked about habit, the psychological pattern, the habit loop. We've talked about all of these stories and evidence of how habits, heck, For God's sake, we've talking about rats. But don't worry, all of this is pointed to one thing. This is to show that with practice and with consistent effort, you can change a habit. So that annoying habit that is dragging you down, that bad habit that's wasting your time, like in my case, it was social media. With little tiny steps and with a conscious effort, and if you untackle the behavioral loop and the triggers and cues, and if you change the environment around you, you can work to consciously change that habit. So fear not, for there is hope. And all this information is to support you and in your journey to become a better person. Now, don't leave yet. Oh my god, you're gonna hate me for this, but I have homework for you. And I know I gave you homework last time, but seriously, this time, I want you. And if you don't have this bad habit, that's great. That's amazing for you. But I want you to stop your screen time or to stop being on your phone or your TV or your iPad 1 hour before you go to sleep. Try that. Just try doing this one tiny small step, and you'll see that you have eliminated the need for technology in the night. And then slowly, you'll find out your triggers and your cues, and you'll replace them with more healthy habits. So, this 1 hour of homework every day, try to stop homework 1 hour before going to sleep. This is Layla signing off, and see you in the next episode.